Good morning, Jeremy.
Good morning.
We're here at Cisco Live in the certification lab area, and one of the things that comes up often is the Cisco Certified Voice Professional. We're hearing in the industry that voice professionals are getting harder and harder to find. What do you think is most important about the CCVP certification right now?
Well, CCVP, I think in the industry, they're just missing, and I think people overall are looking for CCVPs, but you don't find any of them because a lot of people are in the routing and switching world.
Right.
They go through the certifications and then they think, oh, I've mastered it. For example, I went through the typical path, the CCNA, the CCNP. I got the CCIE routing and switching, and I'm thinking, I'm done. I know it all. I'm a CCIE in routing and switching. And
we bow down to you for that.
Oh, well, thank you. But then so my company said, well, why don't you learn voice? And I thought, no brainer. I'll go in. I'll master some of this voice technology, and I got nailed. I walked into to C Voice was the first one, and I'm thinking, okay, I've got the CCIE. This should just be a couple weeks. Everything's new. Everything's different. It's like starting over. It's like knowing Windows. And then somebody saying, well, we'll do Linux, and people go, oh, well, should be
no
different.
problem.
And it just nukes you. So that's what I see a lot of people what's happening with a lot of people. They feel like they have a good base because they're a CCNA, a CCNP, even a CCIE, and then they move into the CCVP realm, and it's just totally different. And most of them just get discouraged right there. They go, well, this isn't for me. I'm not a voice. I don't want to make most common thing I hear. I don't want to make phones ring. So yes, it's just people
Ringing
are overwhelmed.
phones is great.
Yes,
I can speak from experience. C-Voice, though, it was pretty intimidating. And there was a particular theorem that you and I were talking about that just stops people dead in their tracks.
Right.
Nyquist theorem.
Right. Well, C-Voice as a whole is intimidating. It's one topic after another of just, here's something completely new and radically different, especially for PBX people coming into this program. They go, oh yeah,
Exactly.
Nyquist is my bud. I've been there, done that. But
Those are strange people.
But for data folks, it's like the Nyquist theorem. It just can melt you, and then move into regular expressions with translation rules, and then move into some quality of service. There's just so many things in that one course. So you asked, where people get discouraged, and I really think it is C-Voice. It's the first course.
Yep.
They come in and it's just different. So the Nyquist theorem nukes people just because it's theory, and I have to admit, when I first got into this, I called it the NyQuil theorem, just because
Put you to sleep
well,
every
exactly.
time.
I'm waiting for my config T, my where's my commands, and NyQuil, why is this important? But it's so important. It's so amazing. And I think most people in the CCVP get discouraged because they skip over the theorems. They go, well, I don't need to know that. And so when they actually get into the config, they don't really have the big picture behind it. And so they just feel a little bit lost and like, this doesn't all tie together. So the Nyquist theorem, let's talk about that for a second.
Can you give us the 90 seconds NyQuil
the
theorem?
Nyquist theorem. Nyquist, moment of silence for Dr. Harry Nyquist. There it was. Dr. Harry Nyquist created this theory of how to make voice travel further. See, there was a problem. They had all of these analog connections, and the way that the analog connections worked in the day was they're still around everywhere.
Unfortunately.
Right. You would have sound that you have to transmit across wires, and the only way to do that is to use properties of electricity. Matter of fact, there's a conveniently placed whiteboard. Let me show you.
Yes. Convenient.
So here's the idea. You have your voice, the words that are coming out of your mouth is, who's that guy? Chris somebody, famous actor. The words that are coming out of your mouth that are being changed into electricity, and you've gone into Windows, you've recorded the little sound recording, you're like, oh, it's a little wave. It's actually electricity waves that they're using, and they're using the properties of electricity to do that. But the problem is, the farther and farther and farther that goes, the weaker and weaker and weaker that signal gets to where it's almost totally unusable.
That should make sense to data people, though. They have the same challenges, right?
Exactly. With Ethernet and 100 meters, you've got all these restrictions. Same thing with analog. So they'd stick in these little repeaters and regenerate it, but then you get the background noise and everything else that gets nasty. So Nyquist, 50s and 60s came along and said, we've got to fix this. Let's change this from electric signal into numbers. And now this is something data people can relate to. Think of subnetting. You have your byte, right? So we've got our 8 bits in the byte. Zeros and ones, 1 byte. So Dr. Harry Nyquist came along and said, well, let's take this electric signal and find all these points on here and sample it and say, we'll take a little 1 byte sample each time. So 8 bits, you got your 0, 0, 1, 1, your little binary number here, and then package that and send it on its way. So now since you have these binary numbers or these bytes that they're just numbers that can be sent any distance, any unlimited distance across the line, it's no longer an electric signal being sent. So this guy, Dr. Harry Nyquist, far more brilliant than me, figured out that the way to do this, the way to get a good quality voice, is to take 1 second of audio and sample it 8,000 times, to where when you say the word cow, it takes about a second, right? So as I'm saying the word cow, Dr. Harry Nyquist would say, let's take that word and chop it up into 8,000 little pieces, right? 8,000 little pieces, each one of them being 1 byte, or 8 bits, and then put them in packets, or, well, back then a packet, what's a packet? But put them in some kind of thing and send them across a line to wherever the destination is going to be. Now, where was I going with this? Oh, so this, if you have 8 bits in a byte, you're taking 8,000 samples a second, this is where your 8 times 8,000 gives you your 64,000. And that's where a lot of people go, oh, oh, that's where it comes from. That's why a voice call takes 64 kilobits per second, or our T1 lines are in these DS0 channels, and each channel is 64K. Oh, it's all from Dr. Harry Nyquist and how that all puts together. And it's stuff like that. Once people go, oh, I get it. I get that kind of thing. Now you can say, okay, well, based on that, now let's talk about how we can optimize that, how we can make it better. So I think overall what people are missing, I'm throwing my pens down. Dang it, what people are missing.
They're missing the point here.
They're missing the why and the how and all of that. And once they get that, they go, oh, okay, now that I get it and it's exciting, now let's talk about how to optimize that. Now let's talk about codecs and compressing and stripping out certain data so that you can take that 64,000 bits per second and now that I've got my little chart here, you throw G.729 at it, and now you're down to 8 kilobits per second. To where you can magically take that number down and compress it, and now you start finding all of the advantages of voice over IP, and you can do things like VAD and cancel out silence. And when you get the concept of it,
I really do think this is one of the foundations. If they skip over it, all of these other things, how much bandwidth you need for a call, understanding compression in G729, understanding voice activation and how the theorems work and how much bandwidth you need and all of that, they can't pull it together if they don't get this.
Exactly, and it's so tempting to skip too. I'm a nerd. I love getting the commands. I love typing them in and going, oh, it works. It's tied together. So when I first got into voice over IP, I hated it. I hated every second of it because I saw this.
I know somebody else who probably feels the same way.
Skip. Well, I skipped it and I started learning the config and I was like, this is just miserable. So it wasn't until I went back and started going, oh, that's how it works, that it really motivated me to go, oh, okay, well now I see why this all works.
Now, do you use this every day now? Once you learned it.
Do I use the Nyquist theorem every day?
Yes.
Well, in a way, to where I think about it when I'm doing the configuration. Okay. I go, okay, now that I've got my 8,000 samples, I can see how it can trim down. It makes the config make sense.
Very good.
But no, I'm not, outside of just now, I'm not usually going to a whiteboard and drawing up Nyquist theorems and things like that.
Very good. This has been great information. I really appreciate you taking the time to be here with us today.
Yeah, no worries.
All right, thank you.